when calculating the Henderson-Hasselbalch or using the Henderson-Hasselbalch equation, there's a couple ways that we can solve for pH or estimate pH. But the primary thing is that if you understand parts of this equation, it'll be easier to calculate it. So the traditional calculation we'll go over, but what we need to look at first is the equation itself. So the equation is pH is equal to 6.1, which is your pK, plus your log of bicarb over carbonic acid, right? And for usable terms, we're going to use pH is equal to 6.1 plus log of this ratio, HCO3 over your PaCO2 times 0.03. Okay, now something to remember about this is that the CO2 is in torr, and multiplying by 0.03 will convert the PaCO2 to milliequivalents, which will make your ratio workable. So what we're going to look at first is how to estimate your acidosis versus estimate your pH based on acidosis versus alkalosis or normal. So let's look, the main thing we have to remember is that based on Henry's law, the ratio of your combined CO2, which combined CO2 is CO2 with a water molecule, that's your bicarbonate, not a water molecule, your HCO3, and dissolved CO2. Dissolved CO2 is your PaCO2. So let's look at this in normal terms first. So if your bicarb is HCO3 is 24, which is normal, and your PaCO2 is 40, which is normal. Okay, those are both normal values. So according to the Henderson-Hasselbalch, we have to do this equation, right? So let's keep in mind pH is equal to 6.1 plus the log of bicarb over PaCO2 times 0.03. Not very pretty, but y'all get the idea. Okay, so we can't do log by hand, but what we can do is plug in our numbers. Well, first we need to, pH is equal to 6.1 plus your log of bicarb, 24 over 40 times 0.03. Okay, so if we want to calculate this, okay, 40 times 0.03 is 1.2. So 24 over 1.2, and then you want to make this ratio here into 1. So 24 divided by 0.12 is 20 over 1. So your calculation will actually be pH is equal to 6.1 plus the log of 20. So to estimate, we're actually going to stop right there and look at this ratio. Okay, so we're not going to calculate the actual pH, we're going to estimate it. So 20 to 1 is your ratio. The relationship is, we have a range. So our range is plus or minus 2 to be within normal when it comes to your ranges. So let's look at this and figure this out. So the range is 18 to 22, right? 18 to 22. And the relationship is, if this is normal, plus or minus that range, anything greater than 22 means your increase in ratio would be an increase in your pH. So anything greater than 22 would mean an increase in pH. Anything less than 18 would mean a decrease in pH. So if you do this calculation and you get a number that's greater than 22, your pH is increased. That is your alkalosis. Alkalosis. And anything less than 18 would mean a decrease in pH and a decrease in that ratio, and that's acidosis. So given any number, you can figure out if your pH is going to be acidotic or if it's going to be alkalotic. Okay? So let's just throw a number out there. So let's say we have an HCO3 of 33 and a PaCO2 of 30. Okay, so let's calculate this real fast. pH is equal to 6.1 plus the log of 33 over 30 times 0.03. Now I'm just throwing some numbers out here. So 33, this will turn into 30 times 0.03, 0.9. So 33 over 0.9, and your ratio will be 33 divided by 0.9, 36. 36 over 1. Okay, so let's look at this reference. If it's greater than 22, we have your pH is increased, means you'll have an alkalosis based on this ratio. So an increased ratio is an increased pH, which means you have alkalosis. So if your number goes down to 16 over 1, you have less than 18, a decrease in pH, and you have acidosis. So that's how you estimate based on looking at this ratio right here. Okay, so let's take these numbers and actually see this formula at work. So let's do normal. pH is equal to 6.1 plus the log of HCO3 over PaCO2 times 0.03. Okay, let's do normal. pH is equal to 6.1 plus the log of HCO3, which is 24. Let's do that. 24 over 40 times 0.03, which is pH is equal to 6.1 plus the log of 20. Okay, based on those calculations. So let's do this. Borrow my son's phone. If you have an iPhone, smartphone, you can easily, by turning it, guess what? You now have a scientific calculator. Let's do it that way. So, to do this, you take the log of 20, hit log, which is 1.3, add 6.1, 7.40. Okay, so your pH is equal to 7.40. Is that normal? Normal is 735 to 745? Yes, normal. A Let's do this other one. Okay, so calculate your pH. Let's use our example of 33 and 30. It's actually a mixed alkalosis if you're going to really get into it. So pH is equal to 6.1 plus the log of bicarb over your PaCO2. So we're going to say let's do this in a different color. pH is equal to 6.1 plus the log of 33 over 30 times 0.03. Okay, when we calculate that, you have a ratio of 36 to 1. So it will look like this. Okay, and let's calculate that. Okay, 36 log is 1.55, 1.56, 1.56 plus 6.1 . You have a pH 7.65. Okay, let's check it against this estimate. So up here, we had a HCO3 of 33, a PaCO2 of 30. The ratio was 36 over 1. Okay, 36 over 1 is an increased ratio, which means that you estimate an increased pH, which means alkalosis. So let's look at that. Our number down here, pH is, the actual number is pH is equal to 7.65. 7.65, does that fall in the range of normal, 7.35 to 7.45? No, it's actually greater than 7.45, which means you have an alkalosis.